Assalamualaikum and hi. We are from Group K and we will present about Green's theorems and its application. Triple integral in cylindrical coordinates. This is our group members: Muhammad Arif, Muhammad Faiz, Nazin Haziq and Muhammad Kamal. I'm Nazin Haziq and I will talk about introduction of Green's theorem. It can be defined as a relationship between a two-dimensional vector field's line integral and the double integral over the region it encloses over a closed path in the plane. A particular example of Green's theorem is the integral of a two-dimensional conservative field over a closed path is 0. It is used to transform a line integral into a double integral, and sometimes it is used to transform a double integral into a line integral. As you can see here, let C be a positively oriented, piecewise smooth, simple closed curve in a plane, and let D be the region bounded by C. If P and Q are functions of x and y, it can be defined on an open region containing D and have continuous partial derivative there. Then this is the equation regarding the problem solving of Green's theorem. To indicate an integral C is being done over a closed curve in the counterclockwise direction, we usually write counter integral C. We also use the notation partial derivative D to mean the boundary of D oriented in the counterclockwise direction. With this notation, counter integral C equal to integral partial derivative D. If f is conservative, we know that the integral counter integral Cf of dr equal to 0, because any integral of a conservative vector field around a closed curve is 0. We also know in this case that partial derivative p over y equal to partial derivative q over x. So the double integral in the theorem is simply the integral of the zero function, namely 0. So in this case, that f is conservative, then the theorem says simply that 0 equal to 0.
Hi, next I will continue with calculation. This is an example question. Use Green theorems to evaluate integral C 6y minus 9x dy minus yx minus x cubed dx, where C is shown below. This is trapezium. The first coordinate is -1, -1, 1, -1, 1, 2, -1, 4. This is what we get from the integral. P equal to x cubed minus yx, q equal to 6y minus 9x. From this, we need to differentiate partial derivative P over partial derivative y equal to negative x, and partial derivative q over partial derivative x equal to negative 9. Next, this equation, integral C 6y minus 9x dy minus yx minus x cubed dx equal to double integral derivative q over derivative x minus derivative p over derivative y dA. So we transfer this into this, we get double integral dx minus 9 dA. Then we need to verify the equation. The top, the region is given by y equal to 3 minus x. Once we have this equation, the region we can get the limit. This is the limit for x and this is the limit for y. For x, -1 more than equal x more than equal to 1. For the y, -1 more than equal to y more than equal to 3 minus x. After that, we we do the evaluate double integral. Double integral x minus 9 dA. dA we transfer it into dy dx. Then we set the limit for dy is negative 1, y is negative 1, 3 minus x, and for x is negative 1 until 1. This is what we get after we integrate dy. Then we integrate dx. That is what we get after we integrate dx. Then this is the answer what we get, the final answer. Thank you.
Hi, Assalamualaikum. My name is Muhammad Faiz. I will present about the first application of Green's theorem. I will show the example question. The question is, consider the vector field f equal to y to x on the unit this r xy x square plus y square equal to less than 9, and c is the boundary of r oriented counterclockwise. Evaluate the integration of f dr using the Green's theorem. So first step is, we know that f and g is y and 2x. So we need to differentiate it. Y will be 1 and 2x will be 2. Next, we need to draw the graph for the x square plus y square equal to less than 9. This will be the graph with the maximum value is 3 and the minimum value is negative 3. Next, we integrate the value of f dr. It will be equal to integration of f dx plus g dy equal to double integrate with the value of integration with the differentiation of g over x minus f over y dA. Next, we need to integrate with the range of 0 to 2 pi and 0 to 3. 2 minus 1 r dr d theta. So first, we need to integrate with the range of 0 to 3. It will be r square over 2 and will be 9 over 2. Next, we need to integrate with the range of 0 to 2 pi. It will be 9 over 2 theta 0 to pi. Then the last answer will be 9 pi. That's all for me. Thank you.
Alright, thank you to my friend. Hi, my name is Muhammad Arif bin Azari. I will show you how can we apply the concept of Green's theorem in electrostatic analysis. Here is the question. Electric field line cannot form complete loops in electrostatic. However, in electrodynamics, the electric field lines create closed loops that are dependent on Green's theorem, such as the relationship between the integral and differential version of Maxwell's equation and the energy of steady currents. Based on the condition, compute the following line integrals using Green's theorem. So, the equation that has been given is the integration of 1 plus x power of 2 dx minus x power of 2y dy, where c consists of the arc of the parabola y equal x power of 2 from the axis negative 1, 1 to 1, 1. According to Green's theorem, I equal integration of p dx plus q dy. Let's p equal 1 plus x power of 2 and let's q equal negative x power of 2y. Next, we will differentiate the value of p equals negative 2xy and we differentiate the value of q equal to 0. For the next step, we will draw the graph using the equation y equal x power of 2 from the axis negative 1, 1 to 1, 1. This the graph should be looks like. After that, we do the double integration for the value p minus q. We just substitute the value of p equal to negative 2xy and substitute the value of q equal to 0. First, we need to solve the first integration with the limits x power of 2 to 1 dx. Then we proceed to the second integration with the limit -1 to 1. So the final answer will be 0. Hence, the counter integration of 1 plus x power of 2 dx minus x power of 2 y dy is 0. This is the final answer, and thank you.
For conclusion, Green's theorem is a subset of the much more general Stokes theorem. Green's theorem statement that two different types of integrals are equal can be used to compute either type. Green's theorem is sometimes used to transform a line integral into a double integral, and sometimes it is used to transform a double integral into a line integral. That's all from me, thank you.